Hello everyone. Today I'm making new movie in order to deliver you the new chapter of our course. Yes. So this movie we go to new chapter. Yes, chapter 5. Okay. Chapter 5. The title chapter 5 is a survey of probability concepts. A survey of probability concepts. So this chapter we focus on the basic concept of probability. Okay, this is the contents of this chapter. When you have completed this chapter, you will be able to explain the terms, the words, the keywords, experiment, event, and outcome. 2. You will be able to identify and apply the appropriate approach to assigning probabilities. Okay, so after you complete this chapter, you need to know how to identify, how to apply the appropriate or suitable approach to assigning probabilities. Third, you will be able to calculate probabilities using the rules of addition. The rule of addition. 4. You will be able to define the term joint probability or the keyword joint probability. So what does it mean, joint probability? 5. You will be able to calculate probabilities by using the rules of multiplication. The rules of multiplication. 6. You will be able to define the term or the keyword conditional probability. Conditional probability. 7. You will be able to calculate probabilities by using a contingency table. From a contingency table, you can calculate probabilities. 8. You will be able to calculate the probabilities by using Bayes' theorem. Bayes' theorem. 9. You will be able to determine the number of outcomes by using the appropriate principle of counting. So appropriate or suitable principle of counting. Okay, so there are 9 points for this chapter. So back again, you need to explain the terms of the keyword experiment. What does it mean experiment? What does it mean event? What does it mean outcome? In order to identify or in order to apply the appropriate to assigning approach. So we need to know how to apply, how to identify the technique or approach to probability problems that we have or we experience. Okay, we can calculate probability by using the rules of addition. Under the rule of addition, you need to know what does it mean joint probability. We can calculate probability by using rules of multiplication. Under rule of multiplication, you need to understand the keyword conditional probability. 7. By using contingency table, we need to calculate probabilities. By using Bayes' theorem, we need to calculate probabilities of something that happened. And then last one, we can determine how many outcomes, how many results from using appropriate or suitable principle of counting. Okay, so there are 9 points of our chapter goals or chapter content. Okay, chapter 2, chapter 3 that we already watched or studied, those chapters were using descriptive statistics. So chapter 2, chapter 3 were using descriptive statistics that focus on summarizing the data, describing the data, summarizing the data, concluding the data. This chapter will be on inferential statistics. So this chapter, unlike previous chapters, will be on inferential statistics that focus on the computing of chance or computing the chance that something will happen in the future or something will occur in the future. So probability we will use inferential statistics in order to understand the chance that something will happen in the future. Inferential statistics deals with conclusion about population based on sample taken from that population. Okay, so inferential statistics deal with the conclusion about population, but based on the sample that we take from that population. To realize the uncertainty, because when we base on sample result and we conclude or we say something about population, we always make mistake or we always make error. That's why in order to realize, in order to understand the error, the mistake or uncertainty in making conclusion or decision, probability theory will be used to evaluate the risk of uncertainties. Okay, so in order to realize, in order to understand, in order to take the risk or the error or the mistake, we will use probability theory in order to judge, in order to evaluate, in order to understand, in order to determine the risk of uncertainties. Probability concepts are so important in inferential statistics. Probability concepts or probability theory are so important in inferential statistics. Okay, what is a probability? What is a probability? Probability is a measure of chance or a measure of likelihood that describes the relative possibility an event will happen in the future. Probability is a measure of chance, a measure of likelihood that describes the relative possibility of something will happen in the future. A probability is frequently expressed as a decimal number. Decimal number like here 0.50, 0.25 or 0.75. These numbers are decimal numbers that may be given as fraction. That this number comes from the fraction. This is fraction 1 divided by 2 or 1 over 2, 2 over 8 or 2 divided by 8 or 3 over 4 or 3 divided by 4. This expression we call fraction. This expression we call fraction, but for that fraction we call decimal. It can only assume, not measure. it can only assume a value of probability something. A value of probability something must between 0 and 1 inclusive. What does mean inclusive? Inclusive means 0 included, 1 also included. So probabilities of something that we study must between 0 and 1 inclusive. That means including our result or 1 also including our result. The probability of something equal to 1 or closer to 1, this represents something that is certain or more sure to happen respectively. If probability something equal to 1, we are sure, we are certainly something will happen. Or if probability of something closer to 1, we are more sure that something will happen. Okay, this is certain. Certain, that means like strong, like yes, definitely happen. But more sure, we sometimes, yeah, we tend to be more sure, we feel more sure, but not 100%, not certain. The probability of something equal to 0 or closer to 0, this represents something that cannot or is impossible to happen in the future. Equal to 0, that means cannot happen in the future. Or closer to 0, it's impossible to happen in the future. Okay, that's why 1 is also including 1 include, 0 also include in our result. By seeing diagram on page 146, back to your textbook, you can check diagram on page 146. The relationship is shown in the following diagram along with a few of our personal beliefs. Okay, a few of our personal beliefs. Okay, this is probability of something is 0, cannot happen. Probability of something is 1, sure to happen or certain to happen. So you can see diagram here. This is 0, this is 1. Or you can say this is 0%, this is 100%. Okay, so this is 50%, half. Okay, so from 0 to 100% cannot happen to certain happen. Sometimes half. Okay, so this is example 0%. The probability of our sun will disappear this year, 0. Cannot be. Sun's always coming in the daytime. Okay, that's why no sun this year, impossible. Let's say 0.2 or 20%, the chance of good student will come to class late. Okay, good student always come, not always, good student often come to class on time, but few times of chance that they came late because of maybe some business or some emergent task. That's why I can say that 20% of chance that good student come to class late. 50, a chance of head in a single toss a coin. For example, if you have a one coin, normally coin has two sides or two faces. So you toss it or you throw it into the air and then let the coin stop moving. You can see that one head must go up, one face must go up, or one face must go down. Okay, that's why 50%, because there are only two faces. A chance of an increase in federal tax. 70%, let this one, the tax of one country can be increased. We can say 70% tax will be increased in this year. 100%. The chance of rain in August in this year. If we sure that we are sure that, or we are certain that the rain will coming in August this year. Okay, why? Because in August, in our country, in August is a rainy season. That's why rain must come in this year, August this year. Any day in August that rain coming, yes, this is in August. So this is a relationship between our belief. Sometimes you can study this diagram for the other problems, not only belief. Okay. So in short, probability of x is even, x is something that we study. Probability of x must between 0 and 1 inclusive. You can see inclusive equal to 0 or equal to 1. Okay, equal to 0 or equal to 1. That's why this is probability of x is between 0 and 1 inclusive. Okay, to study probability, we will need to use three keywords or three terms are follow. 1. Experiment. What does it mean, experiment? Or what is experiment mean? Experiment is a process of some activities or the act of taking some measurements that leads to occurrence of only one of several possible observations. So experiment is process of doing some activities or the act of taking some measurements that leads to occurrence of only one outcome or only one observation coming among several possible observations. Okay, in this case, for example, we do something. Result coming, it should be there are many possible results. But when at the end of the experiment, only one result coming among several possible results. Okay, for example, I can say that yes, asking how much money in your pocket. Maybe I ask one student coming and I ask he or her, how much money in your pocket? How much money in your pocket? This is my experiment. Because this is the act of taking one measurement in order to understand, in order to see how much money in your pocket right now. Okay, so I can guess that, okay, maybe 10,000 real or 20,000 real. There are many possible results that I can guess. But when this student take money from his or her pocket to count, actual result coming. So among possible result that I guess, only one result coming. That's why this is called experiment. In probability, an experiment has two or more possible results. More or two possible results. Okay, and it is uncertain which one will occur. We are not sure which one will occur. For example, the other case, I asked one student coming and I asked, I called one student coming and I asked how many siblings that this student has. That means how many brother sister that this student has. So I can guess maybe only he or she is only single child, no sibling, or maybe their parent has two children. Maybe he or she with the other one. So I can guess, but I'm not sure which one, how many siblings that this student has. But after asking, he or she answer, I got answer, I got the result. That's why actual result coming among possible result that I guess. So asking how many siblings that this student has, this is experiment because I take the action of measures. Sorry. Outcome. Outcome is a particular result of an experiment. A particular result of an experiment. So in our experiment there are many possible results. There are many possible results coming. But outcome is a particular result. It's a specific result coming. Okay. For example, asking 100 students whether they like to study statistics is my experiment. So I ask, suppose that in this class there are 100 students, and I ask the same question to all 100 students. Do you like statistics? Do you like to study statistics? I ask this question to all. This is my experiment. How about result? There are many possible results. You know how many possible results? Who can? How many possible results? Okay, asking 100 students whether they like to study statistics or not. This is my experiment. My question, based on this, who can answer how many possible results from this experiment? Okay, so I am waiting to hear your answer, and when you answer, you need to explain why you answer this possible result, this number of possible result. One possible outcome or result is that 80 students like statistics. The other possible outcome is that 50 students like statistics. The other possible outcome, it could be 30 students like statistics. The other possible outcome, it could be 1 student like statistics. Okay, these are some possible results. But my question asking how many possible results for this experiment. But I just give you only few possible results. Event is a collection of one or more outcomes from an experiment. So we have experiment, we have outcome, we have event. Actually, event and outcome are similar to each other, but just outcome may be particular one result. Event is a collection of particular one or more result together. Okay, so in order to study statistics, you need to understand these 3 words or these 3 keywords or these 3 terms: experiment, outcome, and event. Okay, so try to understand this one. This is the other example: experiment, outcome, and event. Okay, this is a die. We call die here. Did you know this is a die? And this is a number of member of board director for Fortune 500 companies who are over 60 years of age. Okay, so I have 2 experiments, one rolling the die, the other one asking the member or director from this company that who are over 60 years of age. Okay, I have two experiments, this one and this one. When you roll one die, when you have one die, when you roll one time, make it round, okay, and then let it stop by itself. So all possible outcomes could be observe a 1, a 2, a 3, a 4, a 5, a 6. This is all possible outcome. It could be 1 coming, or it could be 2 coming, it could be 3 coming, it could be 4 coming, it could be 5 coming, it could be 6 coming, because they are 6 faces of one die. This is the possible outcome. Among number of members of board director for these companies, none of them are over 60 years of age. Or maybe one of them are over 60 years of age, or maybe 2 of them are over 60 years of age, or maybe 29 of them are over 60 years of age, maybe 100 of them are over 60 years of age. So these are possible, could be. But when you count actually, you will get 1 only. Okay, this could be, but when you count, you get 1 result. Or it could be 6 number coming, but when you roll one time, the one he face up will come in. This is actual. Okay, this is possible, but not actual. Actual when you see it, when you get it, after you roll it, or after you roll it, or after you asking. Some possible event is a collection of all of one or more outcome of our experiment. Observe an even number, for example 2, 4, 6. So 2, 4, 6 together, this is a we call event of, it should be even number possible outcome, even number possible events, or odd number possible events. Okay, in this case maybe more than 13 our board director are over 60 years of age, or maybe fewer than 20 are over 60 years of age. So this should be we just collect together, we just group together for some specific purpose. Okay, so if you have textbook, you can go to page 146. This one is about probability, experiment, outcome, event. This is what I show you. Okay, this is what you need to study and to find the answers. Okay, cell review 5.1. Cell review 5.1. Video games Corporation recently developed a new video game. Its playability is to be tested by 80 game players, or maybe volunteer game players. So I have, in this case we have 1, 2, 3, 4, 5 questions. Question A, what is an experiment? Question B, what is an possible outcome? Question C, suppose that 65 players tried a new game and said that they liked it. If 65 a probability, why or why not? D, the probability that the new game will be a success is computed to be minus 1.0. Common, it means that the probability of a new game will be success is minus 1.0. Is it true? Why? Is it not true? Why not? That's why common here. E, specify one possible event. Okay, specify. Maybe you can raise one possible event as a specification. So this is your practice. If you can answer this correctly, it means you understand what we have done so far. Okay, so this is just the first self-review in order to check the introduction of probability concepts. Okay, we have approach. Approach means technique or methods. Two approaches, two probabilities, to an event, namely, or two techniques or two methods to study probabilities of one event. They are objective probability and subjective probability. For objective probability is subdivided into the other two we call classical probability and empirical probability. Okay, so for objective probability we subdivide it into the other two techniques, the other two sub approach or sub techniques that we call classical probability and empirical probability. So again, in order to study probabilities of one event, we need to use techniques, or we need to use approach, or we need to use the way to study. There are two approaches, there are two ways, there are two techniques. One is objective probability, the other one is subjective probability. In terms of objective probability, we have the other divided into two sub technique, classical probabilities, and the other one is empirical probability. So what does it mean, classical probability? Classical probability is the probability approach, is a probability technique that we based on assumption that the outcomes of one experiment are equally likely. What does it mean equally likely? They are equally happen. Okay, the result of probability that we study based on classical, the result could be it must be or are equally happen. By using this classical points of view, the probability of an event happening is computed by dividing the number of favorable outcomes. What does mean favorable outcome? The outcome that we want to see, the outcome that we like to see, by the number of possible outcomes. By the number of possible outcomes. That means, okay. So the formula is there. So probabilities of something that we study, or probabilities of one event that we study, equal to the number of favorable outcomes divided by total possible outcomes. Okay, this is classical. Practice example, you can go to your textbook on page 148. It's about die. Okay, so again, just recall or just review, classical probability is a probability technique approach that we based on the assumption that outcomes of one experiment or something that we study are equally likely to happen, are equally likely to occur. Okay, by using this classical point of view, the probabilities of something that we study equal to the number of favorable outcomes divided by total possible outcome. Okay, if you go to textbook on page 148, textbook 448, this one you can see here. Okay, consider an experiment of rolling a 6-side or 6-faces die. We call die. What is probabilities of event and even number of spots? The point here we call spots, 1 spot, 2 spot, 3 spot. Okay. What is the probabilities of even of an even number of spots appear face up? Face up is this spot is going face up. Okay, based on this one, how many even numbers in our one die? There are three. Yes, there are three even numbers in our one die. What are even numbers? 2, 4, and 6. So there are three favorable outcomes: 2, 4, or 6 in the collection of 6 equally likely possible outcomes. That's why the probabilities of an even number of one rolling die is 50% or 0.5. Okay, actually this is not, see this one. So an international standard they say 0.5, 0.5, but it is 0.5. Okay, 0.5, but they don't say 0 because 0 is nothing. That's why they say 0.5. So 0.5 here is international reading, but in order to be clear, we call 0 or we read 0.5, not only 0.5. Okay, but international reading they never say 0.5, they just say 0.5. That's why 50%. Okay, a mutually exclusive event. Mutually exclusive outcome or mutually exclusive event. What does it mean mutually? Mutually it's similar to each other. Exclusive that means exclude from each other. Event that means outcome that exclude from each other. Mutually exclusive event refer to the occurrence of any one event means that none of others events cannot occur at the same time. For example, I can give example in the class. Okay, in the class, I take one student by random, by chance, not by my plan. By random, by chance, that means I don't see all students. Maybe I just take a ball of paper. I make a small paper ball and I throw the paper ball to one student without seeing them. That's why when I throw it, I don't know whether male or female student get my paper ball. If one student get my paper ball, must coming. Okay, must coming. That's why this is one experiment. The result or the event is mutually exclusive. So if one student get my ball, must come or must stand. Okay, I don't know for sure whether the student get my ball whether male or female, but if the occurrence of male happen or occurrence of male get my ball, female cannot get my ball at the same time. Okay, the occurrence of male get my ball means that female cannot get my ball at the same time, because this is we call exclusive. If male coming, female cannot. Okay, so the result is male, the one who get my ball when I throw it, my ball when I throw it, the one who get my ball. Okay, the one who get my ball could if the male get my ball, female cannot. That's why male is let's say is mutual exclusive event from female, or female is mutual exclusive event from male. At one time, only one student coming. One student must be male or female. If the student is male, this student cannot, female student cannot get my ball. If female student get my ball, male student cannot get my ball. Okay, this is mutually exclusive event. In the example of die tossing experiment, the event of an even number and the event of an odd number outcomes are mutually exclusive. When you have one die and you roll it, only one face face up, only one face is up, the other face cannot be up. This face can be odd number or can be even number. But if the die stop moving, we can see the number 1 is face up, that's why odd number is face up. If odd number is face up, even number cannot face up. That's why odd number outcome and even number outcome are mutually exclusive event. Because when odd number face up, even number cannot be face up. Or when even number face up, odd number cannot be faced up. Okay, that's why even number and odd number are mutually exclusive. Collective exhaustive. Collective exhaustive, at least one of the event must occur when an experiment conducted. Okay, or when we're doing one experiment, at least one outcome must be coming. There's no zero outcome. At least one outcome, that means it could be 1 or 2 or 3 or 4 or 5 or 6 coming. This is we call collective because we collect all exhaustive, collect all outcome together. At least one of the events must occur when one experiment is conducted. So when we conduct or when we doing one experiment, there's at least one outcome coming. There is no zero outcome. Okay, outcome must be coming when we do one or when we conduct one experiment. But we're not sure whether how many outcome. It could be 1 or 2 or 3 or 4 or 5. Okay, but not zero outcome. For die tossing experiment, every outcome will be either even number or odd numbers. So the set is collective exhaustive. The set, that means the set or the group of even numbers and the odd number we call collective exhaustive. The set of events is collective exhaustive and the events are mutually exclusive. The sum of probabilities is equal to 1. Okay, the set, the group of even number or odd number, this is we call collective exhaustive. But even number or odd number alone, this is we call mutually exclusive. For a die tossing experiment, this is this is probability. We roll one time, the probabilities of event coming is half 50%, or the event of 50%. That's why when we sum all of these collective exhaustive together, it will be 100%. Okay, so note, maybe I also explain, note in your textbook the probabilities of one event is written by, yes, I just mentioned earlier, previous slide, in a textbook page, 0.5 or 0.98. Okay, 0.5 international readings, they state 0.5, but actually 0.5. 0.98 actually 0.98. Okay, so in order to make it easy for understanding, for international standard, we just say 0.5, we just say 0.98, not 0.5, not 0.98. Okay, so when you read your textbook, don't confuse with this number. Empirical probabilities. Empirical probability is similar meaning to relative frequency concept. Relative frequency concept we already watched or we already learned from chapter 2. Yes, the describing data by using some techniques, graph table. In chapter 2 we already looked at or watched or learned how to make frequency table from qualitative data and how to make a relative frequency table from qualitative data. We also know how to make frequency distribution table from quantitative data, and we also know how to construct relative frequency distribution table from quantitative data. So in this case, empirical probabilities similar meaning to relative frequency concept. The probability of an event happening in the long run is determined by observing what fraction of time similar events happened in the past. Okay, so if you want to compute, or if you want to calculate, or if you want to understand the probabilities of one event that happening in long run, we use experience from the past time, or we use data from the past time. So it means that if you want to study probability of one event based on empirical probability, you need to have past time experience or past time data. This is the formula that we use in order to study probability of one event by using empirical probability. So the probabilities of event happening, or probabilities of something will be happening, equal to numbers of times event occur in the past divided by total number of observations. So number of times an event that we want to study already happened in the past, and divided by numbers of observations. The key to establishing empirical probabilities is that the more observations will provide a more accurate estimate of the probability. That means the more observation from the past, if you want to make, if you want to get, or if you want to have accurate estimate of probability by using empirical probability concept, you need to have more observations or more data from the past. Okay, if you have more data or more information that from the past experience, so the result from empirical probability concept or from empirical probability calculation will be more accurate. It is called law of large numbers. Okay, this is called a law large number. So what is law of large number? Law of large numbers, it stated that over a large number of trials or experiments, the empirical probabilities of one event will approach to its true probability. The empirical probabilities of what or something will approach to the true probabilities. True probability closer to actual probability. So you can see on textbook page 149 and 150. Okay, so based on the textbook example textbook page 149 and 150, you can see this. Especially this is 150. The probability is A equal to 0.98, or probability is A equal to 0.98. The other one subjective probabilities. Okay, the other one is subjective probability. So the first we looked at objective probability. That objective probability subdivided into two: classical probability and empirical probability. Now subjective probabilities. Subjective probability is a technique of probability that we use in order to calculate or in order to estimate the likelihood or probabilities of one particular event in a happening that is assigned by an individual based on whatever current information is available. So subjective probability, in order to calculate or in order to estimate the probability of one event happening based on or by using subjective probability, we need to have current information. If we have more current information, we tend to have more accurate of subjective probability calculation. So subjective probability concept is opposite of empirical probability concept, because empirical probability concept based on the past experience, past data, past time experience, past time data, past time information. But subjective probability concept is a technique that we use in order to calculate probability of something that based on information right now, current information. Okay. If there is little or no past experience, past data or past information on which to the base of probability, it may be arrived at subjectively. That's why in this case, if you don't have past time experience or past time data or information, or we have a little bit not enough to calculate the probability, we need to use subjective, because subjective based on current information available. Illustrations of subjective probabilities is estimating the likelihood or estimating the probability that you will get grade A in this course. So in this case, the probability that you will get grade A, it depends on what? It depends on current activity. Current activity that you doing in the class. Okay? Not based on your past experience. Current activity, for example, homework. Do you submit all homework? Assignment. Did you complete all assignment? Exam. Did you complete all exam? The other one, class attendance. Class attendance, did you join the class all the time? If you complete all of this, the probability of you get A will be more. More that means closer to 1. Okay, closer to 1. But if you not complete this one, 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 the probability of you get A will be closer to 0. Okay, so probabilities of you will get grade A from this course or in this course, it depends on your current activity for this course, not based on the experience. Okay, not based on experience. However, if we go back to empirical one, maybe we assign probability you get A will be depends on your experience. Okay, it depends on past experience. What is past experience? For example, in high school, were you good at mathematics, calculation? Were you good at physics? Were you good at chemistry? Were you good at the other calculation course? Calculation cost. Okay, if you good at high school or secondary school, you were good at calculus course like mathematics, physics or chemistry or the other calculus course. So the probability you get A for this cost will be closer to 1, because in order to estimate probability that you get A for this cost, we based on your experience. We based on the experience, maybe grade 12, grade 11, 10, 9, 8, 7 or 6, something like this. Okay, so this is differently. The probability that you will get A for this course, because this statistics is a calculus course. If you were good at mathematics, physics, chemistry, and the other calculus course in high school, secondary school, your probabilities of getting A for this course will be closer to 1. But if you are poor at, not good at, poor at, if you are poor at calculus course in high school, secondary school, your probability to get A for this course tend to be closer to 0. Okay, so this is an example. This is an example between empirical probability and the other one. This is a subjective probability. So this is a summarize from what we have done. And so this movie we were looking at, or we watched, in order to study what does it mean probability. Okay, what does it mean probability? Approach or technique, or the ways, the means that we use in order to calculate probabilities or something. That we have two approach or two techniques or two concepts. One is objective probability, the other one is subjective probability. Objective probability will be subdivided into two: classical probabilities and empirical probability. Classical probabilities based on assumption that the outcomes of experiment are all outcomes of experiment are equally likely to be happened or to be happening. However, empirical probabilities is a concept that we use in order to calculate probability something that we based on past information, past experience, or past data that's similar to relative frequency concepts. However, subjective probability we based on current information, current data that we use in order to calculate or something, or calculate probability of one event that happening. Okay, so this is the summarize of techniques or approaches or the ways that we use in order to calculate probability of something, or calculate probabilities of one event. Okay, so this is a cell review 5.2. On this page you can do cell review 5.2 for question A, question B, but not question 3. So without question 3, you don't need to do question 3. So cell review 5.2 on this page you need to do is question 1 and question 2, not question 3. And homework. Wait, I will go to homework on that page 152. Okay, this is a review. What you need to do is number 1, number 2, but not number 3. Okay, not number 3, because number 3 is about Dow Jones Industrial Average. We don't know for sure this one. That's why I don't do this one. And next page you can see your homework. Number 2, number 4, number 6, number 8, not number 10. Why not number 10? Because we don't know this A, T, and TA stock. Because we don't know for sure. That's why it's better not to do this one. Okay, so homework on page 152 you need to do is number 2, number 4, number 6, number 8. Okay, so I think it's time for ending this movie, and also it's time for you to watch this movie to learn the basic concept of probabilities.